Hi friends, welcome to GMK tutorials. So ఇప్పటివరకు ఎవరైనా ఛానల్ సబ్స్క్రైబ్ చేసుకోకుండా ఉంటే please subscribe my channel for more details. Okay, so today we are going to discussing one of the most important topic in the flip class, that is nothing but a D flip flop. Okay, so it is a very easy concept. Okay, if you I think all of you having knowledge on SR flip flop. If you don't have any knowledge on that one, please go through the SR flip flop concept in our channel. Okay, so it is easy for you. Generally, D flip flop means that, okay, D flip flop means that data flip flop. Okay, so data flip flop. So here, whatever the input is applied at the input of flip flop, same value is appear at output of the flip flop. So that's why it is called as a data flip flop. Means that whatever the input is applied to the D flip flop, the same input is also appear at output. That means it is a data flip flop. So it conveys the information. Okay. Now let us see the truth table for this one characteristic. So here clock is a enable signal, T is the input and output. So when the clock is 0, no effect. When the clock is 1, if D is the input value, output is also 0. The clock is also enabled, when the D is 1, output is also 1. So this is a truth table for D flip flop, right? So let us see. So we know that SR flip flop previously, right? SR flip flop circuit diagram here. So flip flops are operated based on the clock signal. So for that purpose, I will connect the clock signal for this one. It is a S value. It is a R value. This is a clock signal. Right? All of you having the circuit diagram. Basically, all of you having Q is a output and Q bar is a complement of it. So here, in this case of the SR flip flop, clock signal is enabled. S, R, Q bar consideration when clock is 0. Okay, clock is when the clock value is 0, S value 0 0, it maintains a previous value. Okay, so no effect condition. So when clock is on, so this is also don't care whatever the input. Okay, or else just wait a minute. So instead of this one, we can change these values. Let us see. So no effect, right? So here 0 0 means that it maintains a previous value. That's why it is called as a memory state. When clock is 1, 0 1 condition, it is a reset condition. When clock is high, S value 1, R value 0, it is nothing but a set condition. So 1 1, it is conditioned as a not used. Okay, not used or invalid. Okay, it is nothing but set, reset. This is called as a memory. So if you have any idea, so please guys, you have to remember very important point. So in case of the SR flip-flop, what happens is that set means that here, set means that output is set to 1. Reset means that output is set to 0. So in this consideration, set and reset consideration point of view, you have to remember so here S value is 0 and Q value is 0. So in this condition, when S is equal to 1 and R is equal to 1 is a reset consideration, right? So if S is equal to 1 means that, so if you observe, S is equal to 1, Q is equal to 1. S is equal to 0, Q is equal to 0. That means when the input value S is 1, Q is 1. That means set condition means that whatever the input of S is there, obviously Q is equal to 1. When S is equal to 0, Q is equal to 0. This is nothing but reset condition. So that means you could observe just whatever the S values are there, same values are appear at the output side. Okay. So for this condition, you have to importantly consider the R values also. Here R values also very important. So what is a possible combination? So in this consideration, okay, R value is also important here. So S is equal to 0, R is complement. So S is equal to 1, R is, that means if you are providing the complement of S to the second input, obviously it produces the same input value to the output of the. So based on this consideration, okay, from this we can design the D flip-flop from the SR flip-flop. Simply let us see here, I have to change the small modification. Okay, instead of S, just I will, okay, so this is a D flip-flop circuit diagram. Just I have to draw this one. Okay, instead of S value, okay, so this is a, just you have to connect it S value directly, and input value for the next one is a complement of the next one. Okay, so if you are connecting S, or it may be D. So this is a D flip-flop circuit diagram. Let us see here, when S is equal to 1, what happens that, so this is connected to S is equal to 1 means input is given as a 1, so this is a complement, so 0. So S is equal to 1, R is equal to 0. So 1 0 condition means that it is a set condition. Therefore Q1 Q bar 0. So that the input is 1, output is 1. So when if you are applying S is equal to 0, R is equal to 1, it is act as a reset condition. Okay, act as a reset. So at that time Q is equal to 0, Q bar is equal. So therefore from this diagram we can derive the D flip-flop from the SR flip-flop for our simplicity point of view. Okay, we can designing a one kind of the block diagram at representation. This is a D flip-flop. We can instead of SR, you can also mention that simply it's a D also. Okay, you can mention simply it is a D flip-flop. Okay, so D, it is the complement of D. So for our convenient point of view, we can represent the same D flip-flop in terms of a block diagram. So it is somewhat easy for remembering, right? So for that purpose, I have to represent the D flip-flop as a, okay. So this is the D signal input. This is the Q. This is the Q bar. Okay, this is nothing but a D flip-flop. Okay, this is a block diagram of D flip-flop, right? So internally, this block diagram consisting of a one SR flip flop. So how it is there? Suppose if you are see that one is also internally one SR flip flop is there. SR flip flop, okay, SR flip flop with S is equal to 1 and complement of that value is given as the second input. Okay, Q bar. So for this one, every flip flop must operate. If you want to operate the flip flop compulsory, so you have to apply the clock signal. Okay, this is also important. This is a clock. Okay, here also we are applying the clock signal. Okay, this complete it is act as a R value, right? So this complete circuit is equal to D flip flop. Okay, this is nothing but a D flip flop. So this is an internal diagram how the D flip flop is going to be using SR flip flop. Okay, so obviously input, we know that generally D is the input, Q is output. So clock is enable signal. Clock 1, D value 0, output 0. Clock high, D value 1, output 1. So this is the characteristic table. Okay, so this is nothing but a D flip flop. Okay, so it is very mostly used in so many applications like flip flops and counters applications. Also we can use the D flip flop. D flip flop is nothing but data storage is mostly done with the D flip flop. It stores a 1 bit of information. So why? Because we are calling that. So whatever the input is there here, the same input is present at the Q side when the clock is enabled. So that means the input value is stored in the flip flop. So that's why it is called as a data storage. Okay, data storage is the basic building block for registers, counters, applications. Okay, flip flops are basic building applications, right? I hope this concept is very useful. Okay, I will explain in Telugu also. So D flip flop అంటే ఏం లేదండి. సో ఇట్ ఈస్ నథింగ్ బట్ డేటా ఫ్లిప్ ఫ్లాప్ అని చెప్తాం. ఓకే, ఈ డేటా ఫ్లిప్ ఫ్లాప్ కి ఎలా ఉంటాయి? దిస్ ఈస్ నథింగ్ బట్ ఏ truth table for this one. Okay, so when the clock is high, that time only it produces the output value. So when the clock is low, at that time whatever the input is the same maintains in the output side. So whenever the clock is enable condition, at that time only it works properly. So this is nothing but data flip flop. ఇక్కడ చూసామంటే దిస్ ఇస్ నథింగ్ బట్ ఎస్ఆర్ ఫ్లిప్ ఫ్లాప్. ఎస్ఆర్ ఫ్లిప్ ఫ్లాప్ నుంచి మనం డేటా ఫ్లిప్ ఫ్లాప్ డిజైన్ చేయాలంటే ఫస్ట్ ఆఫ్ ఆల్ యూ హ్యావ్ టు నో ది truth table for this one. So e 1 condition is nothing but e SR flip flop. This is nothing but truth table for this one. Okay, truth table in case of the SR flip flop. So set condition and these are the two important consideration. 0 1 అయితే q value s is equal to 1. So it is nothing but here s is equal to 1 0 condition, q is equal to 1. So when s is equal to 1, q is equal to 1. So this is nothing but set and reset condition. Based on this, and we can design the D flip flop. Okay na? అంటే SR flip flop లో ఎప్పుడు సెట్ అవుతుంది, రీసెట్ అవుతుంది, ఆ కండిషన్ బేస్ చేసుకుని D flip flop ని ఈజీగా అడిగింది. సో s is equal to 1 అయితే ఆ కన్సిడరేషన్ లో మనకి ఈజీగా అంటే both S value 1 ప్రొడ్యూస్ చేసి కాంప్లిమెంట్ ఆఫ్ S దట్ ఈస్ నథింగ్ బట్ R వాల్యూ కానీ 0 కానీ చేయగలిగితే ఆబ్వియస్లీ ఇట్ బికమ్స్ యాజ్ ఎ సెట్ కండిషన్. సెట్ కండిషన్ లో మనకి ఏముంటుంది, బేసిక్ రేట్ వాట్ ఎవర్ ది ఇన్పుట్ యు ఆర్ ప్రొవైడింగ్ ది సేమ్ ఇన్పుట్ ఈస్ ప్రెసెంట్ అట్ ది అవుట్పుట్ సైడ్. సో అలాంటి నేచర్ ఉన్న ఫ్లిప్ ఫ్లాప్ ఏమంటాం మనం, డి ఫ్లిప్ ఫ్లాప్ అని చెప్తాం. సో ఎస్ఆర్ ఫ్లిప్ ఫ్లాప్ S is equal 1 కి అండ్ R is equal 0 కి సేమ్ అవుట్పుట్ ని అవుట్పుట్ సైడ్ ప్రజెంట్ చేస్తుంది కాబట్టి డేటాని మెయింటైన్ చేస్తుంది. సో దట్స్ వై వీ కెన్ కాల్ ఎస్ ఏ డేటా ఫ్లిప్ ఫ్లాప్. సో అందువల్ల ఈ ఎస్ఆర్ ఫ్లిప్ ఫ్లాప్ ఉన్న ఈ మోడిఫికేషన్ జస్ట్ సింపుల్ గా ఎస్ వాల్యూకి ఆర్ వాల్యూకి జస్ట్ చేంజ్ చేసి, ఓకే, సో ఇలా మెయింటైన్ చేసేసి జస్ట్ కాంప్లిమెంటరీ నేచర్ లో ఇన్పుట్ సప్లై చేస్తే వీ కెన్ గెట్ ది corresponding D ఫ్లిప్ ఫ్లాప్. ఓకే, సో దట్ ఈస్ నథింగ్ బట్ D ఫ్లిప్ ఫ్లాప్ అని చెప్తాం, రైట్? సో ఐ హోప్ దిస్ వీడియో ఈస్ helpful for you also. So this is a block diagrammatic representation for D flip flop in terms of SR also. So thank you for watching GMK tutorials.